I'll start the introduction with our first speaker, Dr. Konstantin Sobolev. He is the professor at the Department of Civil and Environmental Engineering, University of Wisconsin-Milwaukee, and the director of the Concrete Sustainability and Resilience Center. He developed innovative and effective technologies for advanced materials, including pigments and coatings, high-performance cement, chemical admixtures, and concrete. His current research interests are in the application of bottom-up engineering in nano admixtures and nanotechnology for cement and concrete, particle packing models, applications of evolutionary algorithms, design, modeling, and application of high-strength and high-performance materials. Materials with photocatalytic properties, hydrophobic materials, 3D printing of concrete, auxetic, and smart stress sensing materials. So let's welcome our first speaker and start with the presentation.
Well, thank you, Aparna, for this excellent presentation and introduction. And yes, today it's my honor to open the session. And again, I have the slide with introduction slide with speakers, just repeating the program. But I'd like to start with inspiration for today, and inspiration of really my work on the work which inspired me to work in the field of nanotechnology. And obviously, many of us were excited with papers of Feynman and the introduction of the nanorobots and manipulation of material at nanoscale. And what was appearing as a concept at the time now is becoming a reality. What we started back 20 years ago as a concept of nanomodification of concrete is becoming a reality. So just while I was preparing for presentation, I searched about the engines which can be molecular driven nano engines, and just a recent paper appeared that there is like new development, just a recent paper on how we can engineer the muscles and engines at nanoscale. And this was inspiration for many of us. I like to also reflect a little bit my personal interaction with the team at Nanotech Institute in Dallas, and with Anwar and Mike. These two guys really influenced my my understanding and my start of my work on nanotechnology. And they developed a very unique approaches to nanopolymer modification. Professor Leticia Torres from Mexico, she worked with me also nanoparticles. And Miguel also was helping me to understand the role of nanomaterials and how these products can be applied. But indeed, the group from Dallas really work on super tough carbon nanotube reinforced fibers. Their polyvinyl alcohol fibers reinforced with carbon nanotubes exceeded the performance of spider silk, which is known for toughness and for strength. And these fibers were demonstrated almost 20 years ago as a concept, and well published, well presented. But we still like to see these fibers to be applied, and they demonstrated the ways how these fibers can be created. And again, with all these properties, we still need to see the application of these fibers in the field. Another interesting inspiration on nanopolymers for me was really exciting design which we have with polycarboxylate superplasticizers, where you can engineer the molecular chains and create superplasticizers which are tailored for any cementitious material, for any specific chemistry, and achieve a specific role. So basically, this is where molecular design in action is really happening. And I really like to see more of this publication, more of this discussion on how we design superplasticizers and chemical admixtures of future, because this is also an exciting field of nanopolymer modification. And I'd like to also mention the pioneering work of Peter Bartos and his starting of the NICOM series and the work on nanotechnology. And again, there are many fields which were discussed by the team, but we really like to look for polymer modification. And yes, we had the nanofibers were one of nano-reinforced fibers were one of these big direction proposed. Again, we talk about 20 years ago, and obviously a molecular assembly of new polymers. Where we are now, obviously this is the reality now. I like to also demonstrate the scale which we presented at our ACI 241 document, where the nanotechnology and how nanotechnology relates to, nanomaterials relate to field of construction materials and specifically concrete. And like to demonstrate this slide, which we often use to demonstrate the role of nanomaterials where they fit in modification of concrete. And when we look at material at nanoscale, classical fly ash, and this is really like beautiful fly ash particle. And fly ash is not considered to be nanomaterial, but if you look at nanoscale, if you just zoom and look for the features there at very small scale, we can understand that material will definitely will have nanoscale dimension, maybe very small quantity. In one of our work, we demonstrated how to use fly ash as very cheap precursor for creating cash-based modifier, which was nanomaterial, and to a successful modification of Portland cement-based systems. So again, fly ash might be really next big thing if we like to deal with production of very cheap nanomaterials for future applications. I like also to mention something which is related to understanding of molecular structure of CSH gel, which again was demonstrated a relatively long time ago and by a group of French scientists. And maybe if you have more questions about this work, you can ask Roland while he is around. He can explain the pioneering work of Eric and his team at, in France. So we really, when we speak about nanomaterials and nanomaterials application in construction and specifically in concrete, we deal with nanoparticles and like such as nanosilica, and but nanoalumina as fibers might be also very effective. We need to look that nanoparticles, when we produce them, very often they are manufactured at nanoscale, but they are very agglomerated. So you can see that the agglomerates are very often present, especially if particles are extremely small. And the challenge is, again, if you look for individual particles, individual nanofibers, yes, we can observe the matter at atomic level now, so you can see the atomic planes clearly seen and defects can be clearly seen and the structure of nanoalumina. But again, this material is bulk, produced from the bulk, and you can see this, let me see if I can still use this laser pointer. Can you see it there? So from relatively large objects, and fibers are perfectly aligned. And nanosilica is, and nanoalumina usually used in very dispersed form. And Brian is here. Brian, we still use your picture. It was it was simple, but still I think it's very good visual that those materials we are not using anymore as powders. We use them in the form of liquid dispersions. And this is the way we handle materials and have them prepared for concrete technology. And again, the way of application of nanomaterials in polymeric applications might be a little bit different, but I believe the challenges we all face, and again, the way I learned how we disperse the nanomaterials and use nanomaterials in composites came from modification of the polymers from the groups I worked. But indeed, when we have nanomaterials available, they come in as in aggregated state, and they come as a bundles, which is still a task to disperse. So there is no magic material in the container which you can add and it's going to do some magic. Someone needs to disperse it. And degree of dispersion, I think this is a big deal, which we still need to understand. But again, we will have presentation on nanodispersion today. To finalize where we are with nano concrete world, and this is again picture from Peter Bartas, which he reported 13 years ago. And at the time, we were like at the bottom of the expectations. We didn't see that technology was really showing implementation in the field, and we were very skeptical about the future. Now, where we are, now we know that technology is gaining traction. It is becoming really a big part of the business, and with a role of institutions like ACI, our committee, a nanotechnology committee, and the NICOM conference is big. I'd like to mention that we are planning new NICOM 8 in Catania, just July 2024. Everyone is encouraged to submit. I'd like to mention some key publications came from ACI on this in this field, and the couple of books and proceedings are available, still available. So what is next? ACI 241 is very active in developing new documents, and we also, ASTM is working on colloidal silica.